This video is the fourth lesson in the Basic Algebra in Full series. To go to the previous video or to access all lessons in this series or playlist, check the video description or pinned comment. Happy studying. Hello and welcome back to Math in Full channel, where everything in mathematics is connected and truly understood. Having gone through addition and subtraction of algebraic expressions and terms and equations, the next logical step is to look at multiplication and division, which is the second family in arithmetic generally. So at the end of this lesson, you would know how to manipulate multiplication and division in algebra. Let's start by looking at multiplication. So say we have 2a times 3a. How do we multiply this? So just like in addition and subtraction, the numbers are multiplied first. So 2 times 3, 6. But unlike addition and subtraction, you don't take just one of the variables. You have to take both of them. So that's the key difference between addition and subtraction and multiplication and division. So to take both of them means that it will be 6a times a. Now, in algebra, you don't write letters in multiples like this. If you have multiple letters, what you do is you count the number of letters they are and put it as a superscript. So this becomes 6a raised to power 2. This a raised to power 2 tells us that there are two copies of a multiplying themselves. So that is how you multiply in algebra. Now don't bother yourself so much about this superscript stuff, because that is the next lesson anyway. Powers. This superscript is what we call powers or indices. So we will look at that in the next lesson. But for now, let's just focus on what multiplication is all about. So based on what we've said, if you add 2a times a, this times a means there's 1 here, you know. So this gives you 2 times 1, 2. Now if you multiply the two a's, it gives you a raised to power 2. So that is just the same thing, just to reinforce what we've talked about. If it was 2a raised to power 2 times a, then same thing, 2 times 1, 2. Then the a will now become a raised to power 2 here. If you put another a on it, it becomes 3. So it becomes 2a raised to power 3. Another key difference to note in multiplication compared to addition and subtraction is that you can multiply unlike terms. So if you had 2a times 3b, if it was 2a plus 3b, you cannot add or subtract. That's how the expression ends. But if you have 2a times 3b, you can multiply this. So multiplication again, 2 times 3, 6. Then a times b becomes ab. That is how it works in algebra. Now you'll be wondering why, if a times b is ab, why is a times a not aa? Because you cannot repeat letters in algebra. Instead of you repeating letters, put it as a superscript. So that's why it doesn't work that way. So you can multiply unlike terms. So the summary of what we are saying so far is that when it comes to multiplication, every variable that you are multiplying must be represented in the answer. That's simply what it means, compared to addition and subtraction where you pick just one variable. In multiplication, every variable must appear. So again, just to reinforce it, let's look at another example. Now look at this example on your screen. 2xy times 5y raised to power 2. Here again, you multiply the two numbers, it gives you 10. 2 times 5, 10. Then xy times y squared is supposed to be xy times y squared. Now x, then because this is already y, 2 here, if you multiply another y to this y raised to power 2, then the y raised to power 2 becomes y raised to power 3, which means there are 3 y's involved in the multiplication. So this will be the answer. Don't bother yourself about trying to find out how do we keep up with this numbering and all. That is why the next lesson on powers exists. So when we look at powers and indices, we will see the short forms, the ways to manipulate this multiplication further when you have so many variables? What are the easier ways? We look at some laws of indices that helps us to manage multiplication of many variables or of variables that have multiple powers. Imagine if this was 10, 20, 21 and so on. You don't have to start adding it manually in your head. You just have to use those laws of indices. So we'll look at that in the next lesson. Let's just continue this. So before we leave multiplication of algebraic terms and go into division, let us look at one last thing, which is multiplication of negative numbers. If you recall, we looked at addition of negative numbers when we looked at addition and subtraction of algebraic terms. So we are going to do the same. We will look at multiplication of negative numbers and see how it works. So first, let us refresh how you multiply negative numbers if it is not algebra. Now, if you recall, we said if you have minus 5 plus 3, the answer is minus 2 because you take the sign of the bigger number. In multiplication, it doesn't work that way. There is no taking the sign of the bigger number. In multiplication, the negative sign, that is minus, is always superior to plus. So if you had this same arithmetic, minus 5 times 3 or times plus 3, then the answer must always be minus, not because minus belongs to 5, but because minus is involved in the multiplication. So unlike addition and subtraction, in multiplication, whenever there is a minus involved, it must be in the answer. So this gives us minus 15. So you multiply as usual, 5 times 3, 15, but you put the negative. So what I'm saying in essence is that even if you had 5 times minus 3, the answer is still minus 15 because minus is involved. It doesn't have to belong to the bigger number. It will still be minus 15. Now, what if the two numbers have minus, just like we did when we were doing addition and subtraction? Minus 5 times minus 3. Now you multiply the two numbers as usual, 15. Then minus multiplying minus gives you plus. So in multiplication, if the two numbers have minus, you multiply the two numbers as usual, the minus becomes plus because minus times minus gives you plus. Okay, remember this is different from addition where if the two numbers had minus, if you had minus 5 minus 3 or minus 5 plus minus 3, you take the minus as the answer, then add 5 and 3 gives you 8. So this is different in addition. Now look at this scenario. If you had minus 5 times minus 3 times minus 2. Now in this case, we multiply the numbers first. Let's get that out of the way. 5 times 3, 15. 15 times 2, 30. Now, minus times minus gives us plus. Then that plus times this minus still gives us minus. So the answer here is minus 30. Now, look at another situation. Minus 5 times minus 3 times minus 2 times minus 4. In this case, minus times minus gives us plus. That plus times this minus gives us minus. Then the minus times this minus still gives us plus. So you see, the point is that it is not automatic that once you see two minuses in an expression that the answer is already plus. It depends on the total number of minuses available. So you keep on checking it. Minus times minus times minus times minus to know the final sign that the answer would have. Or if you want to look at it in another way, once the total number of negative numbers in that expression is odd, then the final answer will be minus. But I don't recommend using that approach. Just multiply the negatives or the minuses as you see them to know what the final answer would be. So just for you to note that, because you need this basic arithmetic knowledge in order to be able to continue your simplification process in algebra. So now let's take a quick example before we move on to division. If you had minus 5a times 3a, what will the answer be? Minus is already there, so minus must be in the answer. 5 times 3, 15. And there are two a's here, so it will be a raised to power 2. So this is the answer for this. Now let's go to division. How does division work in algebra? it is actually not much different from division in basic arithmetic, and is also not different from multiplication. So you divide the numbers and then cancel out the variables until nothing is left. So let's take an example. If we had 8x divided by 2x, you cancel out whatever can be cancelled out, just like the way you do it in basic arithmetic. X will cancel x, and then 2 divided by 2 gives you 1. 8 divided by 2 gives you 4. So the answer here is 4. Now, what about negative numbers? Now, for negative numbers, the minus sign will always persist, just like in multiplication. So if we had minus 8x over 2x, x cancels x, 2 divided by 2, 1, 8 divided by 2, 4. The answer becomes minus 4. So this minus sign will always appear. It doesn't matter if it belongs to the bigger number, smaller number, or wherever it is. It will always be in the answer. But just like in multiplication, if we had minus 8x over minus 2x, that is, the minus is up and down. In multiplication, we will say the two numbers multiplying themselves have the minus sign. In that case, minus times minus is plus. So in division, it's the same thing. The minus will cancel the minus up and down. Then x will cancel x. Then 2 here 1, 2 here 4. So the answer here becomes 4. So you see that similarity between multiplication and division because they are from the same family. So that's what we see here as well. And just like we said for multiplication, if you had more than 2 negative numbers involved in the division, then the answer may be negative. If you had 3 negative numbers or terms, then the answer will definitely have the minus sign in it. But if it is just 2 negative numbers or terms, then it will be positive. So it's when you cancel out that you will now know what is left. For instance, if we had minus 8x, maybe multiplying minus 4x here, then under here you have minus 2x. Then obviously x will cancel x. This minus will cancel this minus. Your answer will still have this minus in it. So that will give you minus 32x. This is just to refresh our basic arithmetic. We will still talk about algebraic fractions in future lessons, but it's better to understand this for now. Now let's look at another scenario in division, because division, there are so many possibilities, so many scenarios that we can see. So what if you had multiple variables? Same principle applies. Just cancel out identical things up and down, and what is left becomes your answer. So if we had 8xy over 2x, so x cancels x, 2 divided by 2, 1, 8 divided by 2, 4. So the answer is 4 times y, which is 4y. So that is also as simple as we've written it. Another thing to mention again, still under this division, is that the division sign can become the multiplication sign if you move the numerator to the denominator. What do I mean? If you had 2a divided by 3, which is the same thing as 2a, what we are saying is that if you want to change this divided by 3 to multiplication, you can say times 1 over 3. So because this 3 is the same thing as 3 over 1, so if you want to change the division sign to multiplication, then the 3 goes down and the 1 comes up, which is the same thing as 2a over 3. So we are just saying that if the question is not written as a division over sign like this, then you can just convert the divided by sign to division and help you to cancel out and then simplify easily. That is all we can do on the refreshers for both of them. Now let us look at a typical algebraic setting that has both multiplication and division and see how these things we've learned will help us solve these questions. Now look at this expression on your screen. 6a times 6b times 5a divided by 3. Now remember, don't forget the previous lessons. We said when you have an expression like this, the first thing to do is to check if all the operators are from the same family. If they are not from the same family, then you have to apply BODMAS, which is the lesson we are going to do in the future. So in the same way now we are looking at this, they are all from the same family, so we can go ahead and simplify. So what do we do here? We convert this first to multiplication. So that gives us 6a times 6b times 5a times 1 over 3a, because if we change divided by 3a to multiplication, it becomes times 1 over 3a. So this is the same thing as saying we can now cancel out because we can pull this over. 3a is below. A cancels one of the a's. 3 divided by 3, 1. 6 divided by 3, 2. So we multiply what is left. 2 times 6, which is 12. And then 12 times 5, which is 60. What of the letters? Letters that are left, A, B. So that is 60AB. So that's the answer. Now let's take one more example before you get your try exercise. Look at this expression on your screen. For us to solve this first, let us convert it to the numerator and denominator pattern to make it easy for us to cancel out similar things or things that can divide themselves. So which means we are going to convert this divided by this and divided by this to multiplication. So that becomes 12x squared y times 1 over 4xy cubed times 6y times 1 over 3x. Now, because all operators in this expression are from the same family, we could rewrite this as 12x squared y times 6y over 4xy raised to power 3 times 3x. Now, if this was plus or minus, we won't be able to do that because you cannot merge or combine terms just like that, okay? But because everything is multiplication and division, this is unique to the multiplication and division family. So we can move all the things on top together like this as multiplying themselves, then divided by all the things below multiplying themselves. Now, another thing you can do in this multiplication and division family is that even the terms themselves, you can split their members, okay? The reason why you can do that is that every term consists of things that are multiplying themselves. So if you had something like 5x, 5x just means 5 times x, or 6y, 6y means 6 times y, okay? So if we had this term this way, we can say 12 times x times x times y, because this is already a setting of a multiplication and division family. So it is now possible to split those terms into their individual items that were multiplying themselves. Now let me repeat, if this was plus, you cannot do that, because if you split these items in this term, then you are likely going to cause a mathematical error. But because this is a multiplication and division setting, we are now doing this. Now you will see why we are doing this, to make the equation neater. So let me take this off first. So now let us rewrite the equation based on the expression, based on what we've discussed now. So that means we have, let's move all the numbers together and all the letters separate, and then separate the letters as well. So we have 12 times 6 times x times x. This x times x is coming from this x squared here, times y times y. This other y is from this 6 that we split the 6 from this 6y, I mean, over 4 times 3, then times x times y times y times y times x. Okay, so we've represented everything, but we've now expanded and made them individual. This is just to make it easier for us to cancel out and then know what is left. Now, let me mention here that the reason why we are doing it this way is because we have not done powers. When we do powers, which is the next lesson, or indices, you will see what we call the laws of indices, which helps us to manipulate variables or letters such that we don't need to spread them out like this in order to simplify them. In their states of superscripts like this, those laws of indices will help us to manipulate them to get the correct answer. So when we get to the next lesson, you will understand what I mean by what I just said. But for now, let us stick to this because we are still in this stage of doing it basic. Okay, so what is the next thing to do to cancel out? So 4 divided by 4, 1. 12 divided by 4 is 3. 3, we cancel 3. Then That's all for the numbers. Now for the letters, this x we cancel this x, this x we cancel this x, this y we cancel this y, and this y we cancel this y. So what do we have left? We have 6 left here on top, and below we have just y left here. So the answer becomes 6 over y. All right, you see how we got that? Very, very easy. Here is your try exercise. Keep an eye on the channel as usual to see the solution, but try it first before watching the solution. So let's call it a wrap on this lesson, which is multiplication and division of algebraic terms. The comment section is always open for comments. You can also send a mail to ask@mathinfo.com. Our website has so many exercises for you to try to solidify your skills and make yourself more confident. Keep studying. Remember, in mathematics, it's all connected.